So hi everyone, my name is Rich, and I have contact information. I started having a Twitter account last year, and now I have like over 100 followers, so I'm kind of a big deal on the internet. This talk is about CSRF attacks mostly, and the outline is, first I'm going to talk about give some background, talk about framework weaknesses, OAuth, practical CSRF tips, and XSS and CSRF protected posts. Some interesting cases of that. In the white paper, but not necessarily in this talk, is some clickjacking and NTLM stuff. So first, background. It's kind of hard to make a CSRF talk sexy. If I gave out a summary and said, okay, here's a talk about CSRF at Black Hat, I'm not sure I would necessarily be interested, because it's a problem that most of us probably think we understand pretty well. And this is a picture from OWASP, and it says detectability easy. And when most of us think about what a CSRF attack is, we kind of think, okay, so this is a solved problem maybe, and CSRF happens when we forget to apply that solved problem. And that's not what this talk is about. This talk is more about, okay, so we've applied the real solution that we think mitigates CSRF, and these are holes around when we've done everything right, when we followed OWASP and followed the SDL, but the areas where we can still go wrong. So first off, what is the same origin policy? This is a question I love to ask when people call in and do phone screens, because it's a simple question, again, that a lot of us think that we understand, but it turns out the deeper you go, it can turn out to be actually really complex. The simple answer, though, is that content from one website, it shouldn't usually be able to access or modify content on another website. So this means, like, if we're logged into Google on one website, Microsoft on the other, they shouldn't be able to interact. But if we open a new tab and want to look at our Gmail content, we still want to be logged in. And that includes like frames, tabs, and sometimes Flash. Unless we tell Flash we want to be able to access other stuff. And a lot of web vulnerabilities happen when websites inadvertently allow cross-site access. So some same origin policy quirks that are useful for this talk. One is it's possible to get or post to any domain. It's the basis for traditional CSRF. A lesser known thing, but still known, is that it's often possible to write cookies from one domain to another domain. And so writing cookies is a lot easier than reading them. To recap writing cookies, here are some attributes that are interesting. So what happens when we write cookies is we make a request, web server sends a response, a set cookie header is in that response. And there are a couple attributes we can set. One of them is path, one of them is domain. These are useful when we want to get our cookie first. I was talking about the same origin policy like 2 slides ago. Which same origin policy are we talking about? So if we're talking about DOM access, like can one DOM access another DOM? Let's look at these two domains. There's pr.woodgrovebank.com over HTTP port 8080. And then there's this second domain that's https secure.woodgrovebank.com. So for most intents and purposes, these are completely separate domains, right? One is HTTP, one is HTTPS. That means like one DOM can't access the other DOM. Another thing is that one is pr.woodgrovebank.com, one is secure.woodgrovebank.com. So, sorry about that. That's what happens when you do a mic handoff. So one is pr.woodgrovebank.com, one is secure.woodgrovebank.com. So again, for most cases, this is completely different origins. So with default Flash, with default DOM, that's a separate origin. Another thing is one is port 8080, one is port 443. Again, that's separate. But one way that they're the same is that they can both write cookies to this top level domain, or not top level, I guess it's second level, but they can both write cookies to woodgrovebank.com if they want. So cookie scope. One interesting thing is, can HTTPS secure.woodgrovebank.com, can it differentiate between cookies that it sets versus cookies that this HTTP PR website sets? And the answer to that is no. There's nothing in the cookie that's sent that you can tell who set the cookie. So here are some useful cookie facts. So these two websites, the prwoodgrovebank.com and securewoodgrovebank.com, they can both write cookies to each other. And so if they both set cookies, then there are 2 cookies sent, but they're indistinguishable. You can't tell which domain set it. Another interesting fact is that all browsers have a limit to the number of cookies in the cookie jar. And so this is very useful. Maybe almost a year ago, John Willender presented something like, he called it triple submit cookies. Okay, and it was attempting to mitigate this problem, he said, and it kind of relies on the fact that if there are 2 cookies sent, then maybe there's a problem, and it does some stuff based on that. But one bypass to that is that you can just send so many cookies that you overflow the number of cookies and just send your attacker cookie. In fact, like just last week, GitHub, they had a cookie tossing thing where, because if you have your own GitHub site, you can execute JavaScript and write cookies. So they tried to mitigate this also by, let's try to detect if there's 2 cookies. But often we can just overflow that. So another thing is that HTTP woodgrovebank.com can overwrite cookies from HTTPS woodgrovebank.com. So again, even though these are different domains, if you're HTTP, you can just completely overwrite them. There's not 2 cookies sent in that case. It's also super common to add or modify cookies based on the DOM. So this is similar to DOM cross-site scripting, not as severe, but it's pretty common, especially with analytic type engines. And another thing is, so we have these websites. A lot of the time we protect against CSRF on the post request. We want to protect against CSRF when we're modifying state. But if you make a GET request to a certain domain, or maybe the login request, or there's all these requests you can do that aren't CSRF protected by design. They don't change the state. But sometimes these requests, like to random parts of the site, which we can make by design, they can set the cookies we want. So sometimes we can just make these requests and then have the application set our cookies for us. So to recap, writing cookies is easy. So this is kind of the background piece, but I want everyone to understand that we can write cookies a lot of the time. Common questions or I guess common misconceptions. What does HTTP only do? So if we set a cookie with this HTTP only attribute, it means that JavaScript cannot access that cookie. So HTTP only has to do with reading cookies, okay? Has nothing at all to do with this. Has nothing to do with writing cookies. So if we set a cookie with HTTP only, we can still overwrite that cookie with JavaScript, okay? What does secure do? It means if we have a secure website, HTTPS, when we set the cookie in the response, we can set this secure attribute. And then when there's an HTTP request, that cookie isn't sent. But again, this has nothing at all to do with reading cookies. Or sorry, it does have to do with reading cookies, but has nothing to do with writing cookies. So if we set our cookie with secure, we can still overwrite that cookie with HTTP. Okay? So one of the first problems we found in this was, we presented this at CCC and Black Hat Abu Dhabi in 2011. One of the most obvious things is this was super common. It's still super common, but it's called, I'll call it for this talk, naive double submit cookies. And so what it does is if there's a cookie in the query string, that doesn't make sense. If there's a cookie and a value in the query string, all it does is check if they're equal. And the assumption is here, okay, so we're in the same origin and only the same domain can write cookies. So if they're equal, then we're probably good and we let this request go through. That's how we protect against CSRF. Obviously, since I've talked for like 10 minutes about why we should assume that writing cookies is easy, this protection is pretty easy to bypass if we can write cookies, right? So an example of this, we showed this at CCC. So what's happening here is this is OA when it was fixed, or before it was fixed. So here's my signature, and I get a mail from an attacker. So OA used to do this naive double submit cookie thing. And so this attacker email, it's kind of hard to read, but one thing you'll notice is that they have the same top level domain. It's this thing, but they have different subdomains. And so this one link, when you click on it, it has a cross-site scripting in it. it's not the same domain, but it's a neighbor domain. And that cross-site scripting executes, it sets my cookie, it sets them to be equal, and then we can bypass the CSRF protection from OA. And so now we've updated it, our signature, which is not a super severe attack, but it's a generic bypass. Or it was, before it was fixed. So now some new stuff. The one thing I wanted you to get from the old stuff is it's easy to write cookies, and there's been some work there. But one thing I started thinking about is what other things do these cookies apply to related to CSRF? So what is the CSRF token tied to? It needs to be tied to something related to the user, right? So this can be a session ID. And that's fine. If it's a session ID, that's actually pretty good. But if it's not tied to the session, what happens if we have two users and we overwrite one user's cookies with another user's? So let's see. One of the questions I asked was, what if the framework, what if you use a framework like .NET or I mean, there's obviously tons of frameworks, and I'll talk about some of them in more depth. But what if it uses the default session ID, but then in your web application you use this custom auth? What happens then? It seems like a recipe for trouble, and it is. So .NET MVC CSRF protection, this is my favorite CSRF protection, so I'm covering it in the most depth. So I have this web application, and hopefully you can, this first thing before the talk I was trying to increase the font, and I couldn't figure it out, but that's okay. This is the only small font. When you read most things about like, okay, how do you prevent CSRF with a MVC app, a .NET MVC app, and they tell you, okay, so you add this validate forgery token to the controllers. And that's usually the extent of the guidance. Okay, so I've done this in a web application, and if I go to that web app, it looks something like this. So, by the way, for this demo, every browser is a different user, so that hopefully makes it less jarring. So this is Firefox user. So Firefox user says best test 44. If we intercept this in burp, it looks something like this. Let's call this Firefox user. So there's some interesting things going on here. So this fed-off cookie, in this web application, I have my own custom authentication, okay? And so the fed-off cookie is what's used for auth. But then I have these other things that are added, and these are related to CSRF. When I do a post, it adds this request verification token cookie, and it adds this request verification token post value. And they're not the same, but they're tied together. And so if you modify even one byte of one, it will throw an exception. And so if you look at where that exception is thrown, you can look at the stack trace. And if you drop this into ILSpy, it looks like this. So you can see there's some information passed to this. Some of that information is a session token and a field token. So the session token is the cookie, the field token is the post value. And so it's tying them together somehow. And one of the things it does really early that you can see is it just compares that they're equal. It says if object.equals the cookie and the post value. So that's pretty much the same as the naive double submit solution that OA had, right? But there's some more information here with MVC. They're also passing this identity field, and that's really what I'm concerned about. If I'm looking to bypass this CSRF protection, I really want to see how does this application know who I am? Because if it's not tied to the session, then I can just replay different users. So what I did was I attached WinDBG to IAS, and I set a breakpoint. So when I make this request, let's turn off our interception. We hit this breakpoint, hopefully. Oh, I'm unauthenticated. So when I make this request with best test 44, I hit this breakpoint, and right off it answers my question. Where does it get the identity from? Well, we can see it right here. It says the identity that's passed in is retrieved from if we click on this, we can see that it's got from system.web.http context. So this is an important fact that maybe isn't documented so much, and it's kind of a tough thing to document. But when we have our MVC protection, we need to make sure that this that our system.web.http context is unique. And if it's not, then it's replayed per user. So let me clear this breakpoint and actually set another one. So let me go back to WinDBG. So what I want to also see, if we go back to ILSpy, we want to see what this binary blob is, because what it's doing is so now that it knows who we are, we want to extract this binary blob, and it sees, okay, who is our user? This is their unique value. And so if we go back to WinDBG, we can go, and we hit this breakpoint right off because it's later in the code. So we can see this binary blob, expand it, and it's actually pretty meaningless. Well, it's not meaningless, but it looks random because it's our claim UID, so it's unique per user. Let's copy this to Notepad. So really quickly, what happens if we change users? So that was Firefox user, and if we go over to Chrome user, our breakpoint is still set, but we might need to make sure we're authenticated. I'm glad they had internet in this room so I could show this. And remember, this is custom authentication. There's nothing wrong with our authentication. The problem is maybe that our application doesn't know how we're authenticated. And so now we're best test 46 for Chrome user. If we do this and hit our breakpoint, one thing we can see is if we look at this binary blob, for Chrome user and IE user, even though the values are completely different, I can show that in a second, but these binary blobs are exactly the same. So if we crack open these tokens and look at the binary blobs, they're the same. So what does this mean? Let's actually remove the breakpoint now. PC star. Okay, so if we make this request again, because I forgot to intercept it, and actually intercept it this time, one thing that we can notice, we have these two requests, one for, oh, oops, I sent it to sequencer. Send a repeater. So we have these two requests, one for Chrome user and one for Firefox user. Well, if you look at request verification token, like, they're completely different. This one is GBLP something, something, something. This is Chrome user. And if we look at that for Firefox user, it's like LRH. So they look completely random, but we looked at that binary blob and they're exactly the same. And it turns out if we replace one, so if we replace Firefox's cookie with Chrome's cookie, well, if we made this request right now, what would happen? We'd get an exception because they don't match. It does that naive double submit thing first. So we made that request, yep, we get an exception. But if we replace both of them, so we replace the cookie and the post value, then everything is happy. And it goes through. So we got a 200. The first one threw an exception, and the second one is a 200. So what does this mean? Or to back up, so how would you exploit this? We've learned that if you can write cookies and we know the post value, then we can bypass this CSRF protection. So in the same app, so I don't have to spend more time copying cookies around, I made a demo. So here I am logged in as Firefox user. I visit a malicious site on the same top level domain, and it sets the cookies for me to the attacker cookies using cookie tossing, and then we've bypassed the CSRF protection. Okay, same as naive double submit. So MVC CSRF, the protection works fine by default, but the information is derived from the session ID cookie automatically. Okay, or sorry, it's not. Well, we just actually went over this. It's not from the session ID cookie necessarily, but it's got from system.web.http context. So if your HTTP context isn't unique, then you're in trouble. What if you auth another way? Sometimes that's fine, as long as it sets HTTP context.user to something unique. So ACS does this. Like, so if you use ACS, that's fine. Or Visual Studio comes with some OAuth templates, and those work fine. But what if in your application you use something like Facebook Connect, or if you use something like the Live ID SDK, or there's tons of things that don't set HTTP context.user to something unique. Okay, and so if you don't do that manually, then your application might be vulnerable to this attack. And worse, a lot of these APIs, like they will force you to set HTTP context.user to a specific value, and so that you can even use that API. And so that makes it difficult. You kind of have to write your own CSRF protection in that case and add that controller. So this is super common. Obviously, it's not just MVC though. MVC is my favorite protection. But one of the more popular ones and common ones is like forms.net. So what do they tell you to do with ViewState? If you have a ViewState, like an ASP.NET Forms app, how do they tell you to protect against CSRF? They give you something like this that says, okay, make sure the ViewState user key is set to the session ID. And I have another smaller demo with this one. But if you look at it, you set that on a base page, so every page gets this ViewState user key set to the session ID. Where do you think the session ID comes from? Well, how does this look in real life? Here's IE user. If we visit this example.com page, unfortunately my auth expires too fast, so it might ask me to re-auth. So we re-sign in. If we make a post request, remember our ViewState user key is set to a unique value. Let's intercept this one. So if we make this request, we'll see some things. First of all, we have this session ID cookie. Okay, and we're using custom auth. We're using the same custom auth for this web app that we were before. So this session ID cookie actually is not used for authentication. This fedauth cookie is. Okay, so if we omitted the session ID cookie and did like a GET request anywhere in the app, it would be fine. But so the protection relies on setting ViewState user key to session ID. What is that doing? Well, there's these ViewState things down here. And we're relying on this to prevent CSRF. Okay, but the reason why they make this recommendation, if we go back to the slide, they say, I mean that's super small, but they say, okay, set a ViewState user key to session.session ID, and they say that so you can't just grab this value down here, this ViewState, grab it from user 1 and replace that for user 2. Okay, so that's why they say that. But where is the session ID coming from? And it's nothing magic. It's coming from this cookie right here. So if we're able to write this cookie, this session ID cookie, across users, then we can still bypass this protection if we're not using session ID for auth. Does that make sense? So we're not using the session ID cookie for auth, so it's a problem. If we modify this, it's bad. But if we copy the ViewState user key and the session ID, and remember, we can write cookies a lot of the time. So if we can write those cookies, then we can bypass this. Okay? Other frameworks obviously have the same problem because these frameworks can't always know about where the user's coming from. So Django, Ruby on Rails, sometimes it's worse. And it can be a problem with any framework that tries to mitigate CSRF across the board because a lot of the times they don't know how we're authenticating. Single sign-on apps, this is also super common. If you think about it, you have a Kerberos app or like an NTLM app. It should be obvious that this is so easy to get wrong because we're authenticating at the IIS level or the Apache level. And so these frameworks are preventing CSRF at the cookie level, right? They're tying our, or not at the cookie, but they're tying a cookie to this post value. So if we assume we can write cookies and we can write these post values, then a lot of the time we can bypass this. So generically, what can we learn from this? If we use custom auth with a standard web framework, this is a really, really common bug. The test methodology is easy. What we can do is we can have one user, grab their information, and replace it with another user. And except for the session ID, but replace the CSRF values. And if that works, you're probably vulnerable. The hard part is figuring out what cookie is used for what. The exploit's a little harder, but again, we're assuming we can write cookies. So if you have man in the middle, cookie injection, neighbor XSS, or anything like that, you can usually craft a real exploit. How do we mitigate CSRF? This is another question I ask a lot of people like on phone screens and things. And the most common answer is, okay, we need a nonce. All right, that's true. What is a nonce? It needs to be unique per user. It needs to be not guessable. And so this is usually what people say. They say it needs to be unique and not guessable. What they usually don't say is that it needs to be cryptographically tied to the session. And so you don't see a lot of people answering like this, but it's actually probably the most common problem, at least the most common problem I see. It's a tough problem to completely automate because we don't know how users are going to auth. They're always going to, if you have a big website, you're probably going to want to auth your own way. So frameworks have tried, and they get all the solutions they can, but they don't know if you're going to use your own SDK or something. And static analysis, it's also a very hard problem because you can never incorporate how someone's going to write code in every case. Oops. So moving on to OAuth. OAuth I thought was an interesting target. Right, let's see how I'm doing on time. So OAuth I thought was a super interesting problem or target because, so what is OAuth doing? You have one user and you have another completely different user. And we're trying to grant access to the application some way with these two different users. That's kind of an oversimplification, but if you have these two users, how do you know which session's which? And mitigating CSRF actually gets really hard. What is the impact of CSRF here? There has been some work. And CSRF mitigations are actually covered in the spec. So there's the state parameter that should be used. And like in a spec, they say, okay, the state parameter needs to be a non-guessable value. It's user agent's authenticated state, kept in a location, accessible only on the client. And so they say, okay, we need to make this state value is passed all the way through the entire flow, and you can use it to theoretically prevent CSRF. One common use of OAuth is tying accounts together. So here's an example. Say I have a Stack Exchange account from 1982 when Stack Exchange was founded or whatever. You have this old curmudgeon-y account, and you want to tie it. So Stack Exchange knows this, and they want you to keep that account. But they also want you to authenticate other ways. So that's the add more logins thing at the bottom. So maybe you want to log in with Facebook, or log in with your Gmail, or log in with whatever. Okay, and that's fine. And a lot of times they use OAuth or OpenID type things to do that. So the first attack ideas I thought of were like, okay, what if we toss cookies into the victim? So we toss cookies into Stack Overflow like we were just talking about with MVC. And then the cookies used for auth may not be used, may not be tied to the identifier because they need to know exactly what the session ID cookie is, and they need to make sure they tie the state parameter to that. So it's an easy problem to get wrong. So then you associate the attacker's account with the victim's account, and you completely own their account. So that was my idea. But there are a lot of cookies for each site. So I was looking at Stack Exchange, and there's a bunch of cookies set, and I was trying to figure out which cookies are used for the nonce and which cookies are used for the post value, and it was, it's not an impossible problem, but it took some time. But there's usually an easier way to own these types of accounts. But the above, so this flow will probably be a problem for a very long time. So my second attack idea was, the one that worked for so many sites was, so one, you create an attacker Facebook account. Two, you grant the accessing application, so in this case it's Stack Overflow, you grant it all the permissions in the world. You say, okay, you can auth to me, you can look at all my friends, I don't care because you're the attacker's account. So we're assuming that the victim is logged into Stack Overflow, and the malicious site does the following. So the victim visits a malicious site, they log the victim in to the attacker's Facebook account. And I was planning on using cookie tossing for this, but it turned out not to be necessary because Facebook had a CSRF in the login. Then we post to the account association request, and there's the state parameter isn't sent in the flow until later. And so then the attacker logs out into the other session. So now we have successfully tied our attacker account to this victim Stack Exchange account. Here's a video of that. So we log into Stack Exchange with my one account, which is victim@live.com. And this account actually does not, this is the only account on this, this Stack Exchange website. So at this point, I haven't tied any Facebook things to it or anything. Then I visit this malicious site, which is sneakily named Stack Exchange Pwn. And so I log into, I'm logged into Stack Exchange. I click this Pwn thing. There's this pop-up, and what this pop-up is doing is logging me into the attacker's Facebook account. Okay, so I'm the victim right now, but I'm logging into the attacker's Facebook account. Oops. Let's fast forward. And so now we post to Stack Exchange, and we can see that our victim account, or our attacker account, is now associated with our Facebook, or sorry, our attacker account is associated with the victim account. Does the attack flow make sense? It's a very cool attack, and it's bad, right? Because if you think about it, we've completely owned their account, and with Stack Exchange, the engineers later told me that you actually could disassociate their accounts, but I couldn't figure out how to disassociate my account. So I owned it like forever, which is cool, but it's also kind of hard to test because you own it once and you need to create a bunch of new accounts. There's some details that I kind of skirted over. So to log into Facebook, they don't really have CSRF protection, but they don't let you set the refer, so the refer can't be set. So this is kind of an interesting problem that took a few hours to think about. So there are a couple ways we can post cross-domain and strip the refer. The easiest way, and the first thing I always try, is there's like an HTTPS to HTTP post, right? So if that happens, then no refer is sent, and we win. But if it's HTTPS to HTTPS, then there is a refer sent, even cross-domain. So we can't do that because Facebook only lets us log in with HTTPS. One of the first things I thought of was, okay, what about CORS post? Like, what if I make a post request with CORS? And this actually probably should have worked. There's this Moz anon flag that, according to the spec, it looks like it almost would work. There might be some problems, but it turns out with all the browsers, the refer is sent, so that didn't work. Then I actually started Googling, has anyone else solved this? And Kotowitz has, I'm sure I mispronounced his name because I just have ever read it. But he has a blog post about this, and it's a good blog post. He talks about how to use the data protocol handler. And you can do that, and it won't send the refer. But I thought about, okay, so why does data work? Why does CORS post should have worked? And the problem with data is it only works with Chrome and Firefox. It doesn't work with IE because IE doesn't support data. But the reason why they work is because it executes in this about blank context. So what we can do if we're an attacker is we can just, okay, let's open up an iframe. Let's open it up in the about blank context. And then we can write to that. And that works in everything. So we can do that and make our post and not send a refer and log into Facebook. So is this just Stack Exchange? have you seen other websites that do this account association thing? No, of course not. So some other examples are, and these, I think for the most part, I think they should be fixed. Woot.com, imdb.com, goodreads.com, soundcloud.com. So MySpace, yes, new MySpace lets you log in with Facebook now. 10 years ago, I would have been Sammy and cool, but no one used, well, I shouldn't say no one uses MySpace, but yeah, you could do this against MySpace. MySpace is coming back. What else? Fox News, Pinterest. Okay, so those ones are all kind of the same exact attack where you do this post and it associates accounts. Groupon is a little different. There's a couple ways you can do this Facebook Connect thing, and one way is you do that full flow where you do a post request, it sends a code back. Groupon uses this different thing. It uses a post message, a JavaScript post message. It has 2 windows or 2 iframes, and they talk to each other. And this is also another common problem, or sorry, common way to connect accounts. So the problem is that Groupon and a lot of these sites don't have X-frame options. So what you can do is almost the same attack, but for that last piece, instead of a CSRF, we use clickjacking. So we do the same thing at first. Right now we're logging into our attacker's Facebook account. And then instead of doing our CSRF attack, now this is actually a clickjacking module I wrote. It's part of Beef right now. And actually this demo isn't that good because I'm screen capturing at the same time I'm doing the CSRF, and for some reason it stopped working as good. But it still works. So right now behind the scenes, obviously this could really be hidden. But it's saying, is this really you? You say, yes, that's me, associate my accounts. And now I've tied my attacker Facebook account to Groupon. And I can log in with that, of course. So yeah, the rest of this video is just log in. Yep, I can log in with my attacker's Facebook. This is my favorite picture in the whole slide deck, by the way. And the reason why is because, so look at this. We have this email change request. And you enter in your email, you confirm your password, and that makes a lot of sense because if you can just change the email, you pretty much have owned their Groupon account, right? And that's very common, right? If we want to change our password, most sites make you enter in your old password. But one thing that most sites don't do, in fact, every single site I checked did not do this, was if you want to connect with your Facebook account, you just click that button. All right, so what does that mean? That means if we find cross-site scripting in any of these sites, then you don't need to re-enter your password. You just can associate it with Facebook and own it like that. So yeah, that's super. I shouldn't say all the sites I test. Every single site I tested except for Flickr. So Flickr makes you enter in your password. Good job, Flickr. Huffington Post did this, same thing as Facebook. They have the post message thing, no X-frame option, so they have the clickjacking thing. Foursquare does this, SlideShare does this, Kickstarter does this. Vimeo's a little different. Vimeo was one of the best ones I tested. They do the state parameter right. So they do something similar to the to Stack Exchange and Woot, where they do this association request, except for they have the state parameter. And as far as I can tell, you can't get around that. But an interesting thing about Vimeo is when I was looking at it and intercepted it, I noticed there's an XSRFT cookie and a token, and they're equal. So what happens if you just send them both to A? Oh, yeah. This is the first bug we were talking about, right? That's the double submit cookie bug. So yeah, you can. One way to exploit this is if you find cross-site scripting somewhere in Vimeo, like mysite.vimeo.com. But another way that's not really talked about so much, and I don't really talk about it that much, but it's the man in the middle, and that doesn't require me to look for another cross-site scripting. So I show that here. So here I'm poisoning the ARP tables, and I wrote a burp extension that I will release as part of this, as part of the white paper. And so if you make a request to Vimeo.asdf/ASDF/ASDF, then this burp extension will, as a response to that request that's random, or not really random, but determined, then it will send back my own JavaScript, and that JavaScript will set the cookie for Vimeo and overwrite the Vimeo CSRF cookie. So when I visit this website, my malicious attacker's website, or I can force a visit to the website because I'm in the middle, all I do is I write that cookie. So here I am writing the cookie in Vimeo.com context. And by the way, it's all over HTTPS, so I'm only intercepting HTTP requests. So like if they make a request to google.com, I can just force them to request a HTTP Vimeo, and then I can set the cookies with that. So I'm setting the Vimeo cookies, and I make that, now the attack, for the rest of the attack is exactly the same. I just log them into my attacker's Facebook, and now my Vimeo account is associated with my attacker account. Okay? Goodreads is similar to the, it has similar problems to Woot.com, Stack Exchange. But one thing I wanted to show is all these use Facebook. And why did they all use Facebook? Because Facebook had a CSRF in the login, so it was the easiest. But remember, we're assuming we can write cookies, and so we can really log into whatever we want. If we can write cookies, we can log into Twitter or Google or Live, because that's how cookies work. So in this example, even though it's all over HTTP, so it's not that interesting, I just show that, yeah, you can log into Twitter and do the same thing. So first, I'm not logged into Twitter. I don't have a Twitter account for this example. But then I visit a malicious page, and I'm in the middle. And so because I'm in the middle, I can write cookies to Twitter, log the victim into my attacker Twitter account, and associate these requests and tie my attacker Twitter account to the victim's Goodreads account. Okay? So it's the same attack. The risk is large. Compared to a classic XSS and a regular page, you can steal sessions. You can do a lot of things with that. And that's bad. And with XSS, you can even do this attack. But this is worse because you usually own their account forever, right? You've completely owned their account. You can once you've associated their account, you can usually disassociate all their other accounts. So you can make sure you're the only owner of it if you want. I've talked a lot about, well, let's check time. 15 minutes. Don't worry, you guys can go soon. There's a lot of custom logic too. So I've talked about this account association thing, and that's like the worst thing you can do, right? If I want to own an account, the worst thing you can do is take over their account. But there's tons of custom logic that we use OAuth for. One thing, and actually these aren't vulnerabilities, they're just because I didn't really focus on looking for these. But this is just functionality I stumbled across. So if you have a LiveJournal account, they use OAuth to, if you look at it, it says like when I post an entry, automatically post it to Facebook. So if I associate my attacker Facebook with that, then maybe if it's a private LiveJournal, it posts all the stuff to me. And so that's still bad. It's not as bad as completely taking over someone's account, but it's still a bug if it has CSRF in it. So this is Microsoft, again, no bug, but they have OAuth here, and so if you can associate your attacker Facebook account with your Hotmail account, then that's bad because it says chat with your Facebook friends, right? So maybe we associate our attacker Facebook account, we can all of a sudden have all our attacker friends be able to chat with you. How do we fix this? So it can be fixed on the consumer side, and it's been fixed a lot of places. What we can do is the state parameter properly tied to a session ID. And we're kind of asking every consumer website, so we're asking Goodreads, all these other sites, we're kind of asking them to fix it on their own. Because it's a hard problem, right? We need to make sure that we've tied it to the session cookie and not another cookie. But it can definitely be solved like this. It's just maybe not ideal because every single person needs to solve it. Can it be fixed on the identity provider side? Maybe. So Facebook again was the easiest because they had CSRF in their login, and they know about it. They said they've known about it forever, and that's okay. You know, I can understand their position that it's kind of a consumer side bug because it is, but you could also make it more difficult to exploit by like not being able to log in quite as easily as if you're an attacker. But you can still write cookies, so it's still probably a problem. I gave them some other suggestions. I gave identity providers other suggestions that might work. Like maybe we could separate the flow for login versus this associated account thing. But there's not a firm way to solve. I mean, we can do things to mitigate it with identity providers, but remember, there's only a handful of those usually. So identity providers are usually Google, Microsoft, Facebook, Yahoo, Twitter. There's only a handful of them. But maybe more. I don't mean to leave anyone out, but when we're talking about the victims or the people consuming the identities, that's definitely a lot more. So the last section, one thing that I kind of skipped over, these attacks are really obvious, right? Like I pop up a window, I'm logging into Facebook with this window. And why do I do that? It's because all these sites have X-frame options on them, and the identity providers do, because like I said, there's only a handful of them. So if we want to do CSRF against someone with X-frame options, it kind of gets a little tricky because we need to pop up this new window, and it's kind of obvious. So how do we hide that? I was looking at some shady sites, and they like popped under my browser. So I'm like, okay, people do that, and so I started looking, how do we do this pop under? I.e., it's pretty easy, but Facebook and Chrome, they explicitly deny that it was a bug, and it said like blur results in window being lowered is possible. So they tried to fix, they kind of fixed it, but it was still possible. Like I'd visit the Pirate Bay and it pops under, and I noticed like a lot of other shady sites did it. So I started debugging the JavaScript, and I spent like 4 hours debugging it. My wife would walk by, and I was scared. She's like, I'm at some porn website debugging JavaScript, and she's like, still, but but I managed to get it finally. Not that she cares, but the 4 hours was. You said you were working. So here's SoundCloud. It kind of had the same problem, but here I try to make it sneaky. So the only difference here is it's a stack exchange problem, but I'm whistling inconspicuously. There's a pop under right now that's logging me into Facebook. Then I close that, and you're now owned. So that video is maybe not as exciting because it's fun to show things, but yeah, you can do it sneakily. And yes, you can log into your Facebook with the attacker account. Another thing, so I went to Black Hat in August, over the summer in Vegas, and they had this firmware CSRF that was pretty cool, but you needed to stay at a site for 60 seconds or something, and a lot of people get around this. They're like, okay, we'll just, they're watching a video, and that's cool, and it really is fine. It's how else do you get someone to stay at a site for 60 minutes? But I thought, I'm not really super sneaky. What if I just there's these functions like move to, move by. What can we do with those? So one thing you can do, it's like if you look at a normal browser session, like maybe we go to Google, maybe we have a lot of Google windows open. But then we also visit this one. So one thing we can do, if it will go there. Oh, am I intercepting stuff? Yep. Okay, so we can use these move by window attributes, and if, say, we click on this, it visits our malicious site, and rather than trying to be sneaky, you just kind of move it all over the place, and it makes it really hard to click on. You can even say, like, I'm owning you, and flash it. Okay. So I thought that one was kind of fun. And you can't even really close it. Like, if you click here, it just goes in the background. You can open more than one sometimes. And which window is it? They all look the same. I think is it this one? Yeah. Okay. So we can close it that way. But for this Facebook attack, we only need, like, 4 seconds. So that'll take someone 4 seconds, right? So that's the in-your-face CSRF. I expect all CSRFs to be like that now. Crashing browsers, this is another interesting thing because a lot of browser defenders, they spend a lot of money on like trying to mitigate exploits. And that's good. I think those are more severe. But what happens when you crash a browser? What happens to your cookies, right? So we want to log a user out or something. Sometimes if you crash the browser, then your cookies all go away. Usually that's configurable, and that's how a lot of browsers do it by default. So here are ways to crash browsers that are like known, and but there's tons of ways to crash browsers. You can probably fuzz one for not very long. It's there's still exploitable bugs there. Another interesting thing is I love features like this. This is a Facebook feature, and it's a good feature, right? So if you're logged into a bunch of accounts, it tells you where you're logged in on, and you can log out of certain accounts. So that's a good security feature. But I like it because, so I logged them in with my attacker's Facebook account. I can use this to just log them off again if I want. So they don't actually own my attacker's Facebook account. So I like it because it's a good feature and it's a legitimate security feature, but you can use it for evil. I'll skip that. XSS and CSRF protected posts. I'll go over this quickly. I don't have much time, but I think there's some interesting stuff here. When I was actually making this slide, I saw a lot of people say, another lame self-XSS found on a website owned by someone. 6 one I found, got to stop finding these. So he could have been talking about anything, but I hear people say that a lot. So they find like a post value and it has a good CSRF protection. How do I exploit this cross-site scripting? If we can write cookies, a lot of times we can exploit it. So billing.microsoft.com, that's where I work, and they were nice enough to let me talk about one I found at work. So say a post XSS exists in a CSRF protected page. How do we exploit this? And there's been some work here, but I think these are always interesting cases, and everyone's a little unique. So here's victim Dave. He's clueless. He's sitting back there too. He goes to billing.microsoft.com and he's logged in. But then Microsoft.com is a big domain, and a lot of the subdomains of Microsoft.com, maybe they're not quite as secure as something like billing, right? So he visits bugpage.microsoft.com. There's an XSS there that's easy to exploit. So maybe that XSS can set cookies as an attacker to Microsoft.com, which is it's the domain over everything, and set the path to be more specific. So it's /subsection vulnerable page.aspx. That's where the XSS might be. And then you log in as the attacker. So the cookies you set are you're logging in as the attacker. And you grab these CSRF token values that are legitimate because you know those for your attacker. So then you make this post request to /subsection /vulnerable page.aspx as the attacker. So now you have script and it's executing in billing.microsoft.com. So it's not executing in bugpage.microsoft.com anymore. But so because we have the script executing, we can actually make requests to /different/paymentinfo.aspx. Okay, but who's this user logged in as now? Well, with this path, he's logged in as the victim because we set the path very specifically to this vulnerable page, right? So we're only logged in as the attacker for that one page, but we can still access content from the victim if we want. So here is some of how I did that. This kind of shows how it works. In this case, bug page was a fixed bug in social.technet.microsoft.com. And it's able to execute script in that subdomain. This actually isn't very exploitable because it asks if you want to actually leave the domain. It says, are you sure you want to leave? And so a real victim would have to click through this. Then it did the CSRF protected post, and now we're executing in billing.microsoft.com, and we can extract content. So the takeaway from that is that if there's XSS and a CSRF protected value, it's probably still exploitable, especially on a big site, at least in some scenarios. Because if you're in the middle, it's almost always exploitable. More generically, it's almost always possible to log in as a victim. That's what we did it's almost always possible to log in a victim as the attacker. And so that's kind of what we showed on the OAuth examples, and that's kind of an underlying theme. We can have our attacker account and log the victim in. So generic takeaways for this talk. Writing cookies is easy. Only use post requests to change state. And all post requests require an unguessable CSRF value. CSRF tokens are cryptographically tied to the session ID cookie, and it needs to be tied to auth, and if it's not, that's a problem. And this goes for cross-domain requests like OAuth 2, where we maybe have to resolve the problem a bit. And also, CSRF-protected post-XSS is usually exploitable. There's some more content in the white paper that I couldn't fit here. It's clickjacking and NTLM relaying stuff. Actually, it's not complete in the Black Hat CD, but we'll post that soon. And that's it. So let me know if you have any questions.